Fiber reinforced concrete, brought to you by Lance Kilbride, Danny Henson, and Derek Dooms.
The concept of using fibers as reinforcement in concrete is not new. Fibers have been used as reinforcement since ancient times. Historically, horsehair was used in mortar and straw in mud bricks. In the 1900s, asbestos fibers were used in concrete. In the 1950s, the concept of fiber reinforcement concrete was one of the topics of interest. Once the health risks associated with asbestos were discovered, there was a need to find a replacement for the substance in concrete and other building materials. Shown here is the historical use of horsehair in the mortar and the straw in mud bricks. Since the 1960s, steel, glass, and synthetic fibers such as polyurethane fibers were used in concrete. Research into new fiber reinforcement concretes continue today.
Common fiber types used today include steel fibers, micro and macro synthetic fibers such as polyurethane, glass fibers, cellulose fibers, natural fibers such as horsehair mentioned previously, polyvinyl alcohol fibers, specialty fibers such as carbon and Kevlar, or blends of several different ones.
Fibers, such as the ones displayed in this picture, are usually used in concrete to control cracking due to plastic shrinkage and drying shrinkage. They can also reduce the permeability of concrete and thus reduce bleeding of water. Some types of fibers produce greater impact resistance, abrasion resistance, and shatter resistance in concrete. The amount of fibers added to a concrete mix is expressed as a percentage of the total volume of the composite, termed volume fraction, or VF. Volume fraction typically ranges from 1% to 3%.
The fibers help carry the load by increasing the tensile strength of the material. Increasing the aspect ratio of the fiber usually increases the strength and toughness of the concrete. However, fibers that are too long tend to ball up in the mixture, creating pumpability problems and workability problems.
For all of the good that these fibers do in the concrete mixture, they do not increase the flexural strength of the concrete, and so they cannot replace moment-resisting or structural steel reinforcement. If the fiber content in the concrete mixture is too high, the fibers will actually compromise the strength of the concrete.
Test blocks, such as the one displayed in the picture, are required for every batch of fiber-reinforced concrete that shows up at the job site. This ensures that the particular batch will meet required specifications. The American Society for Testing and Materials, or ASTM International, has developed a standard test to evaluate the flexural performance of fiber-reinforced concrete using parameters derived from the load deflection curve obtained by testing a simply supported beam under the third point loading using a closed-loop servo-controlled testing system, such as the one seen in the Harry Morrison lab. This particular testing block shows steel fibers, and steel fibers are actually categorized into 5 specific types. Type 1 is a cold drawn wire. Type 2 is a cut sheet. Type 3 is a melt extracted. Type 4 is a mill cut. And Type 5 is a modified cold drawn wire.
Fiber reinforced concrete has many applications. Some of these applications include bridges and roads, commercial, mining and tunneling, warehouse and industrial, ports and airports, waterways, agricultural, precast concrete, and other products. Fiber reinforced concrete can also be interchanged with regular concrete, and it gives you more strength in the concrete and allows you to span further distances with fiber reinforced concrete.
The benefits of polypropylene and nylon fibers in the concrete mixture can have many different benefits, such as improved impact resistance, improved cohesion amongst the concrete, improved pumpability and workability, and improved resistance to freeze-thaw factors. Steel fibers can improve structural strength, reduce the amount of steel reinforcement required, and improve abrasion resistance. Mixtures and blends of the steel and the two different synthetic fibers can be used to combine the benefits of both. Although the steel fibers can increase the strength of the concrete itself, it cannot on its own replace the strength of the steel reinforcement requirements, only reduce the amount required. All fiber types have the potential to ball up in the concrete mixture. This is usually caused by the addition of fibers to concrete that is too dry or in a mixture with not enough fine aggregate.
Thank you for watching our video about fiber reinforced concrete. We hope you have learned something today. If you would like more information, there will be links in the description below.